Hello viewers, welcome to the online course on domestic equipment maintenance. Today, I'll start the session focusing on the fundamentals and operational principles of a power supply. This is a topic included in Module 10 on power supply basis of the course, and in the previous module, we discussed about cooling equipments, that is air conditioning system. In this lecture, we'll discuss about the basic construction and the principle of working of a power supply. The objective of this course is to familiarize how a power supply works, to learn the basic circuit of a power supply with its different components, and the third, that is what is the physics behind the working of a power supply. So, what is power supply and why we need it? So this is the most important question to be asked. Power supply is an electrical device which basically converts electric signal, that is current, from a source to a correct voltage to power the load. Almost all the electronic devices need DC power supply. Generally, for portable systems which consume low power, one can use batteries, but for standard industrial or domestic purpose, we mostly need power supply. Here you can see some pictures of power supplies. First one is used in desktop computers and it powers the CPU. Other two are generally used in electronic laboratories. To understand the functioning as well as the construction of a power supply, you must first know the basics of current electricity. As the theory of current electricity and electromagnetism are covered in Module 1, I'll assume that you know the basics of alternating current and electromagnetism, which are actually required to understand the physics and working of a power supply. Also, I have to assume that you know some basics of electronics such as diodes, PN junction and their construction, etc. Generally, we talk about two common categories of power supply: unregulated power supply and regulated power supply. Due to fluctuation in the AC mains or variation in the temperature, the output DC voltage may cause malfunctioning in many electronic circuits. Because of that problem in an unregulated power supply, we need to arrange some feedback connection for converting the unregulated power supply to a regulated power supply. Let us discuss about regulated power supply. Regulated power supply is the device designed to provide a constant DC voltage of predetermined value across a load terminal, irrespective of the shortcomings like fluctuation of AC mains, variation of temperature, etc. It generally contains a voltage regulating device in addition to the ordinary power supply. The output of the ordinary power supply is then fed to the regulating device from where the final output is drawn. Here in this talk, we will be discussing about the regulated power supply. So you can see the block diagram of a power supply. The block diagram of a power supply has four important components. These are a transformer, a rectifier, a filter, and a regulator or a stabilizer. Let us discuss each block of this diagram one by one. We will also focus on the construction of these blocks and their working for proper understanding of a power supply. On the left side of the diagram, we have the transformer to which we feed the input AC signal. Dear learners, now I'll introduce you the device transformer in very short. Transformer is a device that transforms electric energy from one alternating current circuit to another circuit or to more circuits by increasing or decreasing the voltage. If the transformer transforming energy by increasing the voltage, then it is called a stepping up transformer. While if it operates by decreasing the voltage, then it is called stepping down transformer. Here you can see one commercial transformer which is generally used everywhere, and you can see it in many places. So the basic principle of working of a transformer is based on electromagnetic induction. A transformer has two coils, primary coils and secondary coils. Here in this diagram you can see on the left hand side the pink color lines, those are primary coils, while the blue color lines are secondary coils. Now number of windings on the primary coil is different from that of secondary coil. Generally in a step down transformer, number of windings in the secondary coil is less than the number of windings in the primary coil, and hence the ratio of secondary to primary windings is always less than 1. This kind of transformer are used to change high voltage into a low voltage supply and to distribute electricity over a long range or long distance so that energy loss in the process is minimum. On the other hand, in step-up transformer, number of windings in primary coils is less than the number of windings in the secondary coil. Hence, it can convert low voltage to high voltage. This kind of transformer are used generally in inverters, stabilizers, etc. So this was the first block. Now next block is my rectifier block. A rectifier is a device that helps to convert AC to DC signal, and it uses PN junction diode. So before discussing about the rectifier block, let us first look at a PN junction and we try to understand the working of a PN junction. A PN junction diode is a device which allows electric current to pass through it during forward bias condition and blocks the current when connected in reverse bias mode. Here in this picture you can see a PN junction diode, and this picture you can see the circuit diagram of a PN junction in forward bias condition. So what is forward biasing? In forward bias condition, the positive terminal of the battery is connected to the P-type semiconductor and the negative terminal of the battery is connected to the N-type semiconductor. But if there is no voltage applied across the diode, there is no flow of electricity through the PN junction. Again, when the PN junction is connected in reverse bias mode, the P-type semiconductor is connected to the negative terminal of the battery as seen in the figure. So you can see P-type of the semiconductor is connected to the negative terminal of the battery and N-type is connected to the positive terminal of the battery. Because of this connection polarity, the holes in the P-type semiconductor and electrons in the N-type semiconductor moves away from the junction, but only a small amount of current flows through the junction due to minority carriers. So that means that a PN junction only allow current to flow in forward bias mode, and this concept is used in a rectifier circuit. A rectifier circuit converts alternating current to direct current, and this process is known as rectification. Let us discuss about the rectifier blocks now. So we have two kind of rectifiers. One is half wave rectifier and another is full wave rectifier. A half wave rectifier only can rectify a half of the alternating current. It works only during the positive half cycle of the full cycle of the alternating current. For better understanding, let us consider a following diagram. So here in this diagram, you have a AC source, you have a diode, you have a transformer, and you have a load connected. So a half wave rectifier circuit uses this AC input, and with the help of the step down transformer, it conveys AC signal to the PN diode. The AC signal to be rectified comes through the secondary ends of the transformer as the input of the PN junction diode. Other side of the PN junction is connected to the load, and the load is again connected to the other end of the secondary coil of the transformer. You can see that from this diagram. So during the positive half cycle of the alternating current, the secondary end of the transformer becomes positive, and hence this positive signal is transferred to the PN junction, making it forward biased. So the current passes through the junction and we get the voltage drop across the load. So here you can see in this diagram non-zero V output of the rectifier when the AC is changing from 0 to pi. That is the positive half cycle of the AC. Again, during the negative half cycle of the AC, that is when the AC is changing from pi to 2 pi, so we are not getting any V output through the rectifier because the PN junction is reverse biased at that particular moment. So there is no flow of current through the junction. So that means that during a full AC cycle, only half part of the AC signal is being transmitted to the load, while the other half part is stopped by the PN junction in a half wave rectifier. Now let us discuss about the full wave rectifier. Here in this diagram, you can see a full wave rectifier. So a full wave rectifier is also known as center tap full wave rectifier because we use a transformer whose center is grounded. So during the positive half cycle of the AC, the M point of the secondary is at the positive potential with respect to the ground point G, while the N point of the secondary is at negative potential. Because of this, during the positive half cycle, only diode D1 will be in the forward biasing condition and diode D2 will be in reverse bias condition. So there will not be any flow of electricity through diode D2 during the positive half cycle. Again, during the negative half cycle, point M will be at negative potential while point N will be at a positive potential. Hence diode D2 will conduct being forward biased and diode D1 will not conduct as it is reverse biased. So finally, in a full wave rectifier, we obtain DC voltage for both positive and negative half cycle. So here in this diagram, you can see the output of D1 and D2 diodes during the positive and the negative half cycle of the AC. And hence we get the final rectified output by combining the result of the two. Next block is filter block. Let us discuss about the filter block of the power supply, which contain the filter circuit, and after rectification the output of the rectifier is fit to the filter circuit. So here in this diagram you can see that the output from the rectifier circuit contain both the desired DC component and some AC components. But we need pure DC output at the load. Hence, we have to filter out the AC component from here. This diagram shows at positive half cycle that we have both AC and DC component present, which is fit to the filter circuit. So filter circuit, generally there are three important filter circuit. One, shunt capacitor based filter circuit, LC filter or shock filter. Third one, CLC filter or pi filter. C stands for capacitance, L for inductor and C again for capacitor. Let us first discuss about shunt capacitor based filter circuit. A capacitor filter circuit contains a capacitor and a load resistance which are connected in parallel. The rectified output is applied across the capacitor which has a low reactance. The reactance of a capacitor is defined as Xc is equal to 1 by omega C, where omega is equal to 2 pi times the frequency. Hence we have Xc equal to 1 by 2 pi Fc. And since we are considering a constant capacitor in this circuit, so keeping the constant aside, we can write that Xc is proportional to 1 by F, where F is the frequency of the current and it is inversely proportional to the reactance for a given capacitance C. The rectified output has both AC and DC components, and the AC component has its own frequency f, while the DC component has zero frequency. For DC, the reactance is infinite. That is why the capacitor offers infinite resistance to DC, and hence DC will not pass through the capacitor. The capacitor will only allow the AC to pass through it. The remaining DC signal will pass through the load resistance, and that can be seen in this figure. But still we can have some part of the AC components going along with the DC to the load, which has to be removed by deploying another circuit element. So there is another popular filter circuit which is known as LC filter or Schoch filter. Here we use an inductor in series with the capacitor, and the load resistance are in parallel. Here this is the diagram where you can see that the output of the rectifier circuit is fed across the inductor, and the reactance of the inductor is given by XL, which is equal to omega times L, and this is equal to 2 pi f times L, where f is the frequency of the signal. So for DC signal, as we know, f is equal to 0, hence XL is equal to 0. This means indicator will smoothly pass the low frequency or DC signal while it blocks the high frequency signals. So that is why the inductor has to be connected in series so that it allows DC and blocks the AC. As a result, the inductor filters out the majority of alternating current component, and the remaining alternating current component is now bypassed by the capacitor due to its low reactance for the alternating current. Another possible filter circuit is CLC circuit or CLC filter circuit. So where we deploy two capacitor and one inductor. Here is the circuit diagram. So this filter is also known as pi section filter or capacitor input filter. In this circuit, the majority filter is done by the C1 capacitor as it offers low resistance to the ripple. The remaining filtering is done by the combination of L and C2. This offers the best filter circuit as the output produced by this circuit is almost perfect DC. So here is a comparison of the output produced by the above three filter circuit. So in the first figure, it is the expected output, that is the expected DC output we are expecting from AC signal. Now in the second figure, you can see it is the output of the shunt capacitor filter, while on the other plot you can see the output of the LC filter as well as the output of the CLC filter. So output of the CLC filter that matches with the expected DC output, and hence you can imagine that how perfectly this CLC filter works. Next block is the regulator block, and this is the last block. So it detects some variation in the power supply output voltage. The output voltage may alter or fluctuate as a result of change in the input AC voltage, the load, or any physical factor of the circuit such as temperature. As a result, the voltage regulator circuit is needed to take care of all these problems. Voltage regulator maintains a steady DC voltage at the output terminals. So finally, this is the image where you can see how the AC input is being converted to DC output through different blocks. First one is the input AC, second one is the transformer output, third one is the rectifier output, fourth one is the filter circuit output, and finally after the action of the regulator we have the output wavefront. Let us now discuss some application of regulated power supply. A regulated power supply is an embedded circuit and is a reliable power source which has less noise, less complexity in the circuit and have very fast responses. Many electronic circuit only works with the regulated power supply, as unregulated power can damage this circuit. So it has been used in developing mobile charging circuit, computers, oscillators, amplifiers, etc. They are also used in band power supply. A band power supply is a power supply capable of producing a variety of output voltage precisely for bands testing electronic circuits, perhaps with the continuous voltage change. So let us discuss about different types of a power supply. Generally, power supplies are classed according to their design and functionality. Depending on how they are designed and work, power supplies can be divided in different types. So one, switch mode power supply. Generally, switching regulators are used in switch mode power supply to convert electrical power efficiently. Next, uninterruptible power supplies, that is UPS. A UPS is a type of electrical equipment that, in the event that the main power source is lost, enables a computer to continue operating for a specific amount of time. Next, come to AC power supply. Typically, an AC power supply obtains its voltage from the main supply. This voltage can be increased or decreased to the necessary value by employing a transformer, and some filtering may also occur. DC power supply. A DC power supply delivers a constant DC voltage to the load. Next one is regulated power supply. We have already discussed about the regulated power supply. So let's go to the next one, that is programmable power supply. The operation of this programmable power supply can be remotely controlled by analog input in addition to digital interface. The application of this kind of supplies includes the production of semiconductors, X-ray generators, the observation of crystal formation, etc. Next, linear power supply. Different electrical and electronic circuit employ the linear power supply, which is also called linear regulator circuit, to deliver DC current to the entire circuit. The circuit's primary purpose is to step down the voltage of alternating current before switching it to a direct current. Next component is computer power supply. The hardware component known as the power supply unit of a computer is utilized to convert the power coming from the outlet into usable power for the various components of the computer. Additionally, this power supply prevents overheating by regulating voltage, which the power supply may be manually or automatically can do. Next and last one is battery based power supply. When there is no access to a main supply, battery based power supply enable the provision of portable DC power to equipments. They come in rechargeable and non-rechargeable varieties such as lithium ion and nickel metal hybrid, etc. So here are some diagrams of different power supply like programmable power supply, DC power supply, computer power supply or UPS. Next point, to understand the durability and how to maintain a power supply. No power supply was ever intended to last permanently, and all will fail eventually, either gradually or catastrophically. The time it takes for a power supply to show sign of degradation varies, and it is determined by a varieties of factors. It is crucial to maintain a power supply in order to ensure its long life as well as best performance. So here are a few points which we have to take care of while maintaining a power system. So, maintain cleanliness. Thus, accumulation can obstruct airflow and lead to overheating. So, it is necessary to clean the power supply unit on a regular basis. Next important point is to keep the power supply in a well ventilated area to prevent heat accumulation. Avoid overloading by connecting no more devices to the power supply than its rated capacity allows. Overloading the power supply might cause system instability or failure. Connect your power supply to a surge protector to defend against power surges or voltage fluctuation. And inspect the power cable and connection on a regular basis for evidence of looseness or damage. Maintain the temperature of your power supply using hardware monitoring software or BIOS setting. And the last point, avoid exposing the power supply to high temperature. So at the end, we came to the conclusion. From the above discussion, we have learned in details about the different components of a power supply. We have learned about the construction, function, and working of different components of a power supply. So after watching this lecture, a student should be able to answer the following question. What is a transformer? How does a transformer work? Next question, what is the difference between a step-up and step-down transformer? What is a power supply? Next question, what is rectification of alternating current? Next, what are the two types of rectifier? Next, discuss the working of half-wave and full-wave rectifier. What is forward biasing and reverse biasing? How does a PN junction work under forward and reverse biased condition? Next, what is shunt capacitor filter? Draw and explain the diagram of a LC filter. Next, explain the working of a CLC or pi filter. Next, why does a capacitor not allow DC to pass through it? Next, what is ripple? Why do we need a regulator in the power supply? So these are a few questions. I hope that the content presented in this session will contribute to expanding your knowledge. Please post your questions and queries and give your feedback on the session. Thank you.